Today I'm going to be talking about your 7.3 notes over arcs, chords, and sectors. A chord, we've already talked about chords, is a segment with endpoints on the circle. So this would be a chord, this would be a chord. And what this creates, we call this an arc associated with this chord. Two minor arcs are congruent if and only if their chords are congruent. So if RS is equal to TV, the segments, then arc RS is equal to arc TV, and vice versa. If we know that the arcs are the same, then the corresponding segments are the same. So here we are told the arcs are congruent, and we want to find x. Well, if the arcs are congruent, the segments are congruent, so 2x plus 3 equals 8x. So 3 equals 6x, so 3 divided by 6 is 1/2. Okay, here I have the segments are congruent, which means the arcs are congruent. So here, I need to figure out what this distance is. So I'm going to take 360 and subtract 64. That gets me 296. So this is 64. Everything else is 296, which means the arc will be half of that, which is 148. Okay, so you should try the next two. So if the arcs are the same, the segments are the same, the chords, so we set them equal to get 2. Here, if the segments are the same, the arcs are the same, so x is 2. And we can have congruent arcs and congruent segments even if they're on different circles. If we know they're the same length or the same circle, so if V is congruent to W, that means it's the same size. If this is 198, this is 162, so this arc length is the same as this arc length, which means these two things are equal. So 9x minus 78 equals 3x. So negative 78 equals negative 6x. So we get x equals 13. We're also then actually asked to find the length of the chord. So they're going to be the same thing. So 3 times 13 is 39. So both of those chords are 39. All right, you should try the next one. So again, the circles are congruent, the segment or the arcs are congruent, so the chords are congruent. So set those equations equal to get 6, plug it back in to get 36 for the chord length. The next concept, in a circle, if the diameter or radius is perpendicular to a chord, then it bisects the chord and its arc. So in this picture, if WZ is perpendicular to AB, then two things are true. The two segments created are congruent, so AX is congruent to XB, this segment and this segment. The arcs are also congruent. So arc AW is congruent to arc WB. So let's use this in a problem. So if this is perpendicular, OD is 15, CD, this whole thing is 24. Find OE. Well, you can kind of tell we have a little right triangle. If this is 24 and this is perpendicular, then each of these segments are 12. So then to find OE, I'm just going to do the Pythagorean theorem. So when we solve all this down, you will get x is equal to 9. Okay, so in this circle, the radius is 13, RS is 24. We're going to find each measure. Well, if RS is 24, then each of these are 12. So RT is 12. PT, this little segment here. Well, in the last problem, we found this distance using a right triangle. So what I'm going to do is draw in a segment to make a right triangle. Well, the radius of this circle goes from the center to the edge, so this segment here is 13. So I've got that's 12, that's 13, and I'm solving for that side of the triangle. So x squared plus 12 squared equals 13 squared. So x is equal to 5. And then to get TQ, if the radius is 13, TQ is going to be 13 minus the 5 we just found, or 8. So now it's your turn to do the last one. Okay, for this one, we have a diameter of 12, CD is 8, and CD, the arc, is 90. So DE is going to be half of that, or 45. FD is going to be half of 8, or 4. And then for AF, I drew in a radius, labeled it 6 since the diameter is 12, and then did the Pythagorean theorem to get 4.5. So that is your notes over arcs, chords, and sectors.